Hello and welcome back to my OpenGL 2D game tutorial series. In this video we'll be talking about VAOs, VBOs, and shaders. We'll render a small rectangle that has a cool gradient of colors across it, and we'll go through a bit of theory regarding the two object types VAO and VBO. Let's talk about these OpenGL objects. VAO means vertex array object and VBO stands for vertex buffer object. So what do these things do then? Well, first we have to know what a vertex is. In computer graphics, a vertex is a single node on a shape. So let's say that we have a triangle, and a triangle consists of 3 points, or rather 3 vertices. And a rectangle has 4 points, so it has 4 vertices, and so on. For every node on a shape, there is a vertex. In OpenGL, we usually work with only triangles though, which is why rectangles are made up of 2 triangles just like this with a diagonal. So now we know what vertices are. What are VBOs? Well, they hold information about these vertices that together describe a shape. And they look much just like arrays of floating point numbers. Perhaps the information you could store in there could be positions of all the vertices, their colors, texture, coordinates, anything you'd like. What about a VAO then? A VAO can contain multiple VBOs, and these are stored in the VAO's attribute lists. You could, for example, create 2 different VBOs, one that contains all the positions of the vertices for a shape, and the other holds all the specific colors for every vertex. These 2 VBOs can be put inside of a VAO to later be used when rendering this shape. So a VAO is then a sort of container for VBOs, or rather any kind of OpenGL buffer. Important to note as well is that we can format a VBO to look however we want. If we wanted to, we could include the color data inside the same VBO that we have the position data in. OpenGL supports interleaved vertex data, which means that we can specify something like this. And then when we put this VBO into our VAO, we tell OpenGL that, hey, I have interleaved data in this VBO. For every 5 elements, the first 2 are the positions and the last 3 is the color. This is, of course, heavily simplified. This is pretty much what you're doing though. And this can, at larger scales, lead to better performance compared to having multiple VBOs in the VAO. We've been talking a lot of theory now, so let's actually get to some coding. To get something to render, we need to create our VAO, then create a VBO, fill this VBO with some kind of data that represents our shape. Then we tell the VAO the format of the VBO, if there's interleaved data or not, and then we can try to render the shape. And for you to get a sense of what is needed for all of this work, we're going to do all of this in the test game class, and once we have fully grasped it all, we can move every distinct bit of it into fitting classes of their own. So OpenGL references all of its objects using number IDs. So let's start by making a couple of variables at the top here that are going to represent the IDs for the objects that we're going to be creating. These are the VAO and the VBO. Then we have to make sure that when we're fiddling with OpenGL that it is initialized and ready, which it is in the load content method, just like we said in the last tutorial. So we do it right there. First of all, we create our VAO with the GL_gen vertex array method. Next, we need to create our VBO, so we do the same but this time with GL_gen buffer. Then we have to make sure that we bind our objects before we attempt to do anything with them. So we start by binding our VAO since we want this VAO to be our shape. To bind the VAO, we simply call GL bind vertex array. Right after that, we bind our VBO, but this time we have to specify what type of buffer it is, and it is of the type GL array buffer. So now that both the VAO and VBO are bound, we can fill the VBO with a bit of data. But we need that data first. I'm going to give you a certain array of data, which you can just copy from the description into your project, and I'll explain these in a little bit. Simply copy and paste this array of vertex data into your project, and now we have the data that needs to go into the VBO. So let's go ahead and put them in there. We do this with the GL buffer data method, where we input which type of buffer we want to apply the data to. We bound our VBO to the GL array buffer type, so we want to fill the GL array buffer for this data to apply to our VBO. The size of it is how many bytes the actual data is, and simply enough, this is just the size of a float times how many floats there are in the vertex data array. Vertices.length. Easy. But here we stumble upon a problem. It is expecting our data to be of type int pointer, which we don't have. We have a float array. Well, fortunately, there is a quite easy way to fix this. We surround this GL buffer data method call with something called a fixed statement. And as you start writing fixed, you won't really get some kind of auto-completion for it. And that's because the method is not declared as unsafe. Once you do that, you can try to write fixed again, and you'll see that it doesn't really complain. It says fixed right there. So in this fixed statement, we want to write float asterisk And then we say v is equal to and vertices index 0. And then we want this buffer data call to be inside of there. Just like that. Now what this actually means is that we want to get the address of the first value of the array as an int pointer, which is exactly what we need. So we input this new variable v right into here, and then it's expecting some kind of usage, and we'll just say gl static draw. Wonderful. The last thing we need to do is to tell the VAO the format of the VBO. Since I gave you the data, you'll probably not know the format of it, but I do since I made it. The format of it is like the example I showed you before when explaining VBOs. There is interleaved data in the VBO, first two being the X and Y position, and the last three being the RGB color values of it. So to tell our VAO the format, we use GL vertex attrib pointer. And our VBO is using interleaved data with two different types of data for every vertex, the positions and the colors. So we will tell our VAO to use two different attribute lists, even if they point to the same actual VBO. So we start with index 0, and let's make the first attribute list be the positions. So the positions consist of X and Y positions, so the size per vertex should be 2. And then we have to say what type the data actually is, and those are floats, so we say GL float. And we don't want these values to be normalized, we want them to be as they are right now, so we can just type false. The next parameter is the stride, so we have to specify how many bytes there are between the first pair of XY positions to the next. And since we have 5 float values per vertex, XY.RGB, we have 5 times size of a float. So 5 times size of float. The last parameter is the offset from the start of the array to the first appearance of this vertex data. And our X and Y positions are the first thing in the array, so we have an offset of 0. Like that. Now this won't be accepted as a just 0. We have to cast it to some kind of pointer, which we can just do void asterisk like that. Last of all, we have to enable the vertex attribute list with index 0. So we do gl enable vertex attribute array 0. Now we just have to redo this for the colors. This time we want the colors to be in attribute list of index 1. So we say gl vertex attribute pointer index 1. The size is 3 since there are 3 color values per vertex. They are of course floats, and we do not want them to be normalized. The stride for these color values is also 5 times size of float. The last offset parameter we set to 2 times size of float since there are 2 floats, the X and Y positions before the first color values. And of course this won't be accepted as it is, we have to cast it to a pointer just like that. And then to finish off, we simply say gl enable vertex attribute array 1. That was almost all of it. Now we simply unbind the VBO and VAO now that we're done creating them. So we just say gl bind buffer 0 and gl bind vertex array 0. Simple. So now we have a shape in our VAO. It's time we try to render it. We go down to the render method, and first of all we change the gl clear color to actually just be 4 zeros, which means that we want the screen to be completely black canvas every frame. And we keep the GL clear to be GL color buffer bit since this will perform the clear with this color. Then we just have to bind our VAO and then call GL draw arrays of GL triangles 0, and there are 6 of them. Then we can unbind the VAO right after this as well. Now we can try to start it. Weird. Nothing happens. Actually, it's not weird. It's because in the OpenGL programmable pipeline, we have to use GLSL shaders to render anything. Lucky for you guys, I've made a couple of standard shaders that will work perfectly for us. So down in the description, there are 2 strings, which are the shaders we will be using. Copy those into your project as well, just like this, above our VAO and VBO creation. Perfect. So let's just quickly go over these shaders. So shaders are basically small programs that sit on the GPU to be used when rendering your models or shapes. So up top, we have the vertex shader, which has one specific job, and that is to position every vertex correctly. So we just have to set this GL position before this program actually ends. Below is the fragmentShader, which also only really has one job, and that is specifying the color for every fragment, which is really the same as every pixel. The vertex shader runs first, and then the fragmentShader is right afterwards. So we can pass values between these from the vertex shader to the fragmentShader, but not vice versa. So let's look at the vertex shader. First 2 lines say layout location equals 0 in vec2 aPosition. Right, so in our VAO, we specify the attribute list at index 0 to be the vertex position, which is the X and Y positions right here, and the attribute list at index equals 1 to be the vertex color, right? And those are 3 values, and these are 2 values. Perfect. So the location keyword specifies which attribute list we are trying to look at, and the position is vec2 since it's 2 floats for every position, and the color is a vec3 since there are 3 color values for every vertex. In the vertex shader, we have also specified a variable to be out, this vertexColor, which basically means that we have to set that variable to a value before the program ends. And in this case, it is going to be the color of the vertex. So we just pass along the color that we get from the VBO to the out variable, just right here. Then in the fragmentShader, we specify an input variable called the exact same thing. And then we can say that the output color of the fragmentShader, which is this out vec4 FragColor, should be equal to the color in the VBO, since this comes from here and this comes from right here and this comes from the VBO. Perfect. So now we have a little bit of a clue what the shaders are doing. Let's actually try to make them work. We need a new object ID at the top to be the ID of the shader that we'll be creating. So we're going to name it shader. So right below the shader code, we create a temporary new variable called vs and call gl create shader, gl vertex shader. Perfect. Then what we have to do is we have to add the actual vertex shader code to this shader, and that we do by gl shader source. And all that's left is to call gl compile shader. Now we just have to do the exact same thing for the fragment shader. So we say uint fs gl create shader. We add the code to it and compile it. Now we have created the vertex and fragment shaders in OpenGL. Now we just need the complete shader program, which is the combination of these 2 shaders. All we have to do is say shader equals gl create program. Then we have to attach the vertex and fragment shaders with gl attach shader, and then we link them together with link program. And that's done. So now we go down to the render method, and right before we bind our VAO, we do gl use program and input our shader ID. Save that and try to start it, and you should see a beautiful little rectangle. The structure that we have right now is obviously not very good. It's all over the place, really. So next time we'll tidy it all up, move the shader stuff into a shader class, and talk a little bit more about shaders and what those numbers in the VBO actually mean. If you want more of these videos, leave a like and subscribe. Thank you for watching.